Hirabami is a really weird and interesting Leviathan monster from Monster Hunter Wilds that is able to use a lot of the old underwater Leviathan animations because it swims through the air with its kind of bizarre sail. And so I wanted to do a little bit of a talk about it and try and answer some questions that I think I and a lot of other people had about its biology. So whenever I talk about a monster from Monster Hunter game, I always give it a Latin binomial name, just like it was a real species, because I think it helps me organize it better in my mind as like a real animal. So I've called uh, Hirabami Paveromobra borealis, which means similar to or other Remobra, and northern. I say that because I think it reminds me a lot of Remobra, and it lives in the Ice Shard Cliffs, which is a very northern area. When it's folded up like this, Hirabami's tail initially reminded me a lot of this structure that remoras have on their head that lets them stick to other animals or boats. And it turns out that that wasn't really far off from the truth because Hirabami use their tails to stick to the icy cliffs and the ice chart cliffs. And they kind of secure themselves and they hang down like a little banner. You can see that in the opening cutscene that they do that. And I think that's really cool and really interesting. And these kind of teeth on the tail aren't actually teeth. They seem to be just very highly modified scales. A lot of the leviathans have movable scales that are attached to muscles in a similar way that bird feathers are attached to muscles. This is very visible in Hirabami and Jindahat specifically, where they can kind of flip their tail scales in and out. And so I think that's very cool. One of the most interesting behaviors that Hirabami has is that it is a colonial nester. A lot of species of birds are colonial nesters, um, and it's a pretty common behavior. But it's very interesting to see represented in Monster Hunter, and I thought that was really cool. A lot of birds, when they do colonial nesting, they'll fly out to sea and gather on an island to get away from predators. But Hirabami does it hanging, which some birds do. They gather in trees. Herons, I believe, create colonial nests in trees. And initially, as soon as I knew that Hirabami started to exhibit this behavior, which you can read in the Hunter's Notes, it says the colonial nester, and you can see Hirabami kind of hanging in groups around the ice shard cliffs. Initially, I was like, why do they do that? What is the ecological reason behind them being colonial nesters? What benefit does this infer? And the first reason that I came up with, and then turns out the main reason for colonial nesting is that it makes it easier to avoid predators. Hirabami's not really high up on the food chain, and young Hirabami absolutely would not be. If Hirabami was a solitary nester, a single Blango could probably come in, eat all those eggs, and have a really, really lovely day, but that would be a very bad day for the Hirabami. The first benefit of colonial nesting is that when you're in a big group, it makes it very unlikely for one individual predator to take your specific offspring. So if a single Blango comes into a nest that has 10 Hirabami hatchlings, it could probably eat all of them. But if there's 400 Hirabami hatchlings, that Blango can't eat all of them. And so for all of those Hirabami parents, just pure chance gives them a survival advantage. More individuals also mean more safety if they're actively defending the nests. A Blango might try to sneak past one Hirabami, but it's not going to risk fighting 10 or 20 of them. And more individuals also just mean more eyes to help detect predators, more ears, just a better, more safe warning system than one parent would allow. Colonial nesting is that it makes it easier for all of the parents to find food because all of these individuals are in one big area, and that serves as an information center, basically. They can exchange information about foraging sites and just gather food more efficiently, whether they're predators or herbivores. Another thing is that in colonial nest sites, less prosperous parents that are worse at finding food can just steal food from other parents. So, in that way, being like a large individual that steals food from other nests with more efficiency can kind of replace being a good hunter. And so that allows for a diversity of survival strategies in one area, which helps the population survive. And it also just allows for a broader survivability across the board for the offspring. So now that we know that Hirabami might gather in groups to make hunting and feeding easier, it's good to ask what it's eating. And we can look at two things to figure out what any given animal is likely eating. We can observe its behavior and we can observe its physiology, which is the shape and structure of its body parts. So, in terms of behavior, Hirabami is somewhat territorial to other carnivores, which indicates that it might be competing with them for foraging area. It gets pretty territorial around Blango and Blanganga, so it's probably eating something at least similar to them. Hirabami also spits ice that has almost no effect on large animals, but it freezes smaller animals like the hunter in position. So, that to me says that it's probably pretty specialized in eating small prey, along with the relatively small size of its mouth and the arrangement of its teeth. But that's starting to get into physiology. So, starting from the back end of its body, it's skinny and flat past the head. It can go after small prey items that have worked themselves into crevices. Hirabami itself doesn't really have a need to hide that much because it can fly. It can get to areas that don't require camouflage to avoid predators. So if Hirabami is like 100 feet up on a vertical cliff and it's just hanging there, it doesn't really need to be camouflaged. It just needs to be up there. So Hirabami being flat is less an adaptation for avoiding larger predators and more an adaptation for going after prey that's worked its way into crevices. Its tail claws are mainly used for gripping walls, but they are also used for attacking small prey. Um, they would be pretty bad at damaging large animals because of how kind of thin and laterally compressed they are. You can see the claws are actually very, very, very flat, even though they're broad if you look at them like from the bottom of the tail. And that indicates that they're going to be pretty weak structurally, and so they would be pretty bad at tearing through like thick hides of large animals. And that indicates to me that if Hirabami has this behavior of attacking with its tail, but its spines aren't particularly well adapted for attacking large animals, that means it's doing the majority of that attacking to smaller prey that it won't damage its spines with. And the thing that, of course, tells us the most about what a given animal will eat is its cranium, its mouth, its jaw muscles, its teeth, all that sort of stuff. So Hirabami's head, just like the rest of its body, is pretty thin and flat, but it can actually expand out quite a lot. It has this big distending jaw like a lot of snakes do. It has these big crushing plates on the outside of its mouth here. They're these kind of like big bony chunks. There's one on each side of the mandible, and there's one on the maxilla. And it also has these very broad crushing teeth that are arranged in rows. Rather than just being in like the front of the mouth, these crushing teeth kind of follow all the way down. And when you see teeth kind of going down the gullet of an animal like that, that can sometimes indicate that it's trying to trap small prey from getting back out of its mouth. So Hirabami isn't crushing something very large and taking pieces out of it. It's probably eating stuff that is still alive when it's entering the mouth. Generally, that sort of broad, flat crushing tooth suggests a diet of invertebrates. There are three primary species of invertebrates that I think would make a good meal for a Hirabami, an adult Hirabami at least, in the ice shard cliffs. Vespoids are pretty rare, but they're around. And also, a cool note is that Hirabami is resistant to paralysis, so it might be preying on Vespoids quite frequently if it's built up the resistance to their venom. Baby Nursilla are everywhere. They're annoying little freaks, and they will always mess up your hunt if you're not careful. But for Hirabami, seeing a bunch of baby Nursillas is a good day because at least I think it's probably going to eat a lot of them. Also, these Kamakchi, the sleep bugs, they share a lot of territory with Hirabami, and I imagine that because they haven't developed some kind of specific Hirabami defense mechanism, that they're probably going to be on the menu for Hirabami and its big crushing teeth. They're kind of the perfect size to fit into Hirabami's mouth. We see this sort of tooth arrangement in nature in a few places that I think are really cool. So the animals that have teeth the most similar in structure to Hirabami are the insect and cephalopod eating lizards. This is one genus of insect eating lizard. It's Salvatore, the Argentine tegu. They eat snails, bugs, all sorts of stuff, and they have pretty typical lizard teeth in the front of their mouth, but in the back of their mouth, they have these big crushing teeth that they use to get through snail shells. And then over here is Galapagos. This thing is massive. It's a giant marine lizard from the Cretaceous period. It's pretty widespread. There's many species of Galapagos, but they have these very bizarre teeth that kind of look like mushrooms when you take them out of the jaw. They look like that, and they're basically just hammers for crushing the shells of ammonites. This is a practice that we call durophagy, when you're eating hard-shelled animals that have adapted that hard shell as a defense, and so you as a predator are specialized breaking through that shell to get the juicy, undefended meat inside. Some other notes that I have on Hirabami's biology, because I think this creature is fantastic, and I love the way that it kind of ties into the other monster designs. After a kind of thorough-ish examination, I think that Hirabami, Balahara, and Jindahad are probably quite closely related to each other. They have general body plan similarities, but there are a few traits that they all share that basically none of the other leviathans do. They have external gills, but they don't breathe. They only breathe air. They don't live in water at all. They have very highly kinetic skulls. They all have skulls that have loads of bones that slide and move past each other, which isn't something that you see in a lot of leviathans in the same way. Uthduna has a very kinetic skull, but it's not kinetic in the same way that Hirabami, Balahara, and Jindahad have. And they also have an unusually high number of tooth rows. Uthduna only has one row of teeth. Most leviathans have at most two, but these guys all have like 4 rows of teeth in their bottom jaw. It's pretty crazy. Hirabami obviously has like teeth out the wazoo, but Jindahad and Balahar also have much more teeth than any other leviathan does. But they're not all the exact same. I think Jindahad and Balahara are probably more closely related to each other than Hirabami is to either one of them. And that's because Hirabami doesn't have these sort of false eye structures on its face. You can see here, Hirabami only has one pair of eyes. But Jindahad and Balahara both have little tiny eyes that kind of dot their face and act as, I assume, like photoreceptors or some other structure like that. And to me, that indicates that Jindahad and Balahara are probably quite closely related. Compared to Hirabami, it's kind of an outlier. It's in the outgroup, which I'll explain what I mean by that in a second. Hirabami also lacks mineralized scales. It doesn't have mineral deposits in its scales like Jindahad or Balahara do. So what do I mean when I say outgroup? When we, as biologists, paleontologists, botanists, any group of scientists talking about an outgroup, we're talking about something that is being excluded to define a clade. A clade is a group of organisms that are more closely related to each other than they are to anything else. So if we take this clade, and let's say that this clade is all antelope. So this is a sable antelope. This is a bongo antelope, and this is a nyala. These are all very lovely species of antelope, and I think they're all antelopes, but it doesn't matter because I know my outgroup is going to be something less related. So this is our clade right here. These animals all definitely share a common ancestor. Technically, every living thing forms a clade because evidence suggests a universal common ancestry, a first form of life that everything then evolved from. But if we want to get more specific, which we have to as scientists because we're in the business of being specific about things, we can form clades that are more organized. And so to form those clades, we define our in-group, which is these 3 guys, and an outgroup. And so for us, this outgroup will be a tegu, that lizard from before. And we know that this tegu is definitely less related to all of these organisms than they are to each other. And so these organisms form a clade because they are each other's closest relatives compared to the outgroup. And so what I'm doing is I'm putting Hirabami out with this tegu, and I'm putting Jindahad and Balahara in this area. I'm saying that they're more closely related than Hirabami is to either one of them. So yeah, those are my thoughts and musings on Hirabami. I think it's a super cool creature design, and I really love it. If you have any questions or corrections to make, I do always love that. Please leave them in the comments below. Or if you're watching this on TikTok, you can send me a DM or comment or something like that. I really do appreciate anyone's input to this. I don't come up with all of these ideas on my own. I bounce them off my friends. I read papers. Science is a collaborative process, and so it's important to get other people's input. I want to give a big thank you to all of my paid subscribers. You guys are super awesome, and I couldn't do this without you. So thank you to Splift, DJ, Cake Chad the Vast, Brick Floatsmore, Joe Evans, Ian, and Gremlin Hours. You guys are really great. If you're a paid subscriber, you get access to the Discord where you can get scans of all of the art that I do, not just the ones for the Monster Hunter series, but all the art period. And you get to shoot me questions at any time. Sometimes we play games together. Probably not this month though, because I'm out doing field work, and so I don't really have the best internet connection. But thank you so much to all my paid subscribers. I really appreciate it. And thank everybody for watching. I hope everybody has a lovely day, and let me know which monsters you'd like to see covered next, or which topics in paleontology, biology, evolutionary ecology, anything like that.